Hi, welcome to the last part of Chapter 3. Today we'll be talking about the last network, 802.11 networking terminology, covering pages 91 to 102 in the textbook. So let's start with some basic terminology. You're going to see the term basic service as BSS, and basically it's just a set of interconnected 802.11 devices. But it's also used for the infrastructure BSS. There's terms BSS and infrastructure BSS are used interchangeably. And what that infrastructure BSS actually means is I've got 802.11 devices connecting to a single access point. So if you have an infrastructure BSS, you must have an access point managing all the devices. Now, the BSS ID it identifies the BSS. Now, technically, it is the MAC address of the AP, and sometimes we better know it as the SSID because it's usually an alphanumeric name that helps us identify the access point we're connecting to. So the service set identifier, the SSID, just identifies the BSS in words versus the hexadecimal MAC address. An independent BSS, an IBSS, is a set of interconnected 802.11 devices, but without an access point. Sometimes it's called an ad hoc network. So the BSS has an AP, an independent BSS does not have an AP. The basic service area, BSA, is basically just the coverage area that the BSS is servicing. And an extended service set is when you interconnect one or more BSSs together, usually through an Ethernet backbone. But for the most part, next two couple of pictures will show you what these are. So here you got the explanation. You got the BSS and the IBSS. That's the independent. So you can see that the independent does not have an access point. The BSS has the access point and all the devices connecting to it. Remember that the BSS is identified by the the BSS identifier, better known as the SSID. Now, remember in theory, the identifier is the MAC address, but the SSID is just an alphanumeric term that we can better understand it. And then, as you can see, the independent has no access point. They're just connecting to each other. And then the extended service set has some kind of shared Ethernet. It doesn't have to be Ethernet, but most of the time it is. It's just a standard that allows to interconnect one or more BSSs. They're interconnected. These BSSs are interconnected through what they called a shared distribution system medium, DSM. And for the most part, DSM is just a shared network for all the BSSs, APs to connect. And like I said, in most cases, it's an Ethernet. It can be a wireless network, but for the most part, we use it as a Ethernet cable. Now, how do I locate a wide area network or a wireless LAN? There's a couple of different things we do. One, there's something called a beacon frame. It's a frame that the AP transmits several times a second, and it includes information about the BSS, how it's managed, and information that can be used by clients that want to locate and connect to that. Or it can be done with what we call a probe request, where frames are actually transmitted by the client on a channel that attempt to locate a proper AP. So it includes information, the types of stuff it's looking for, and then there's probe response. And the question is, why do I have beacon frames, probe requests, and probe responses? Because there's two different ways that we can get access to an AP. One is through passive scanning that uses the beacon frames to locate a good AP for connectivity. So there's information in that beacon frame, not just the SSID, but it could also, the client can look at the received signal strength of that beacon frame to determine if it's the best AP to connect to or not, based on its signal strength. A client typically will scan beacon frames on multiple channels before selecting that best AP to connect. So that's passive scanning. So that's where the client is looking for, it's scanning to see what's the best one. Now there's active scanning, where now I can use these probe requests and response frames. The client will then, move to different channels, sending a probe request on each channel, and then waiting, and you may hear the term dwell, but it basically means I'm waiting on each channel for some period of time, waiting for the probe response. Now, active scanning must be used when I'm connecting to APs with hidden SSIDs. Why? Because I need that information, so I don't see one out there, I've got to probe it, see if it's out there, and then versus just having it broadcast on the beacon frame. And then there's a process that we go through when we find that local area network that we want to connect to. So whether it's through passive or active, the client will connect to that selected AP through a process, connecting that as defined by the 802.11 standard via what they call the state machine, the 802.11 state machine, and which can be either one of 3 or 4 states, depending on if we're using 802.1x EAP authentication is used. So all clients start out as unauthenticated, unassociated, so they haven't been assigned to an AP, they haven't been no passwords have exchanged place. So it's just a way of just saying, hey, we're all starting with, we haven't connected anything. Then the first state that involves some kind of relationship with the AP is the authenticated unassociated. In most modern wireless LANs, the authentication reference is the open system authentication. No credentials are used in the authentication process, but the frame exchange takes place for the client to move into this state. After that, we go to the authenticated associated state. More frames are exchanged to move to this state. When open system authentication is used, the client is now connected and can communicate with the wireless LAN. However, if you're using the 802.1x authentication, now you got required to use the pre-shared key or the extensible authentication protocol, EAP. One more state must be reached. When the 802.1x authenticated state has been reached, the client has encrypted keys and can use them to encrypt communication between the AP and decrypt communication received from the AP. Most enterprise networks use 802.1x, and most public hotspots use open system authentication only. Now, there's one thing to keep in mind, that when 802.1x NET1X authentication is used, successful authentication is followed by a four-way handshake. This handshake is used to transfer information that leads to generation of the encryption keys on the AP and on the client. And then once the handshakes are completed, then all data communication between the client and the AP can be encrypted. Now, there's a couple of different ways that we communicate on wireless LAN. So we've made access to it, we've connected to it, we've been authenticated. But now, how do I put messages on the wireless network? There's something called carrier sense multiple access. There's two different types, collision avoidance, collision detection. Wireless uses collision avoidance. But basically what carrier sense multiple access is, carrier sense is, it senses if the physical media is available for communication. And then multiple access says it gives me a method in which multiple devices will be accessing the medium. Now on 802.3, the Ethernet networks that you have in your desk, maybe at school, it uses carrier sense multiple access collision detection. And collision detection says when detection occurs when two devices are transmitting at the same time. And when that detection has been detected, both devices that are sending or wanting to put network data on the network back off. They go silent for a random amount of time. And it's random for both sides, so the odds of both trying it again and causing another collision is minimized. Now, wireless networks use carrier sense multiple access collision avoidance. In this case, the device's signals that it wants to communicate something, and it kind of says, hey, I've got this much data I want to send, I want to access this much time. So broadcast that out to have everybody go through and make a decision. And then there's a function called the distributed coordination function, the DSF, that controls, how a client should contend to gain proper access, to be able to attempt to access the medium. Some of that's waiting a little bit. Because wireless ends in our carrier sense, we've got two different ways that wireless does it. We does a physical carrier sense, so it says, does the physical carrier exist? Do I have availability? So it uses this clear channel assessment, the CCA, to determine if the airwaves are being used. Now, the CCA monitors the medium to determine if RF energy is detected that maybe exceeds a certain threshold. If it exceeds a certain threshold, then hey, it's busy, I gotta wait. And the second tool that wireless LANs use is the virtual carrier sense. In this case, it uses a network allocation vector, an NAV. And basically all a NAV is a timer on each station. If your timer is at 0, you can contend for the medium. If it's greater than 0, you must wait. So just knowing that you're checking the physical, you've got some timers, and then also the DCF also uses a way to handle this, that each station must wait a period of time called an interspace frame. So between each frame they're sending, you're waiting a period of time before communicating. I know that's a lot of detail, but some of the videos I think should help clear some of that up. So that puts us to the end of chapter 3. So things you want to make sure you remember in this case is, one, the original 802.11 standard was released about in 1997, and only the PHY remaining in production from that initial standard is DSS, 3 S's. The DSS PHY supports maximum data rate of 2 megabits with one lower data rate of 1 megabit and operates in the 2.4 gigahertz range. The HR, the high rate DSS, introduced an additional data rate frames of 5.5 and 11 megabits per second and operates in 2.4 gigahertz. Both the DSS and the HR DSS use 22 megahertz channels. The OFDM PHY operates in the 5 gigahertz and supports data rates up to 54 megabits. The ERP PHY operates in the 2.4 gigahertz and support data rates up to 54 megabits. The high throughput PHY, the HT PHY, operates in both 2.4 and 5 gigahertz, supports data rates up to 600 megabits in the standard, but production we're probably getting 450 megabits. The very high throughput PHY operates only in the 5 gigahertz band and supports data probably up to 6.9 gigabits per second. Now keep in mind that the 802.11i introduced security enhancements. 802.11e introduced quality of service enhancements, passive scanning and active scanning, open system authentication. There's no credential validation, usually for public hotspots and guest networks. 802.1x authentication can be used either in a PSK, personal network, or an EAP, an enterprise network. And then remember that carrier sense multiple access collision avoidance is used in 802.11 wireless LAN to double check if the median's free in communication on the network. So hopefully that helps, and make sure you go through all the material for the rest of this chapter. Like I said, there are 3 sessions in this, 7, 8, and 9. So when you get ready for the test, take it all in consideration. Talk to you later. Bye-bye.